a pleasure to have Kevin Scannell from the University of St. Louis here today to give his second lecture this morning. He spoke earlier to the Irish department. Kevin has his undergraduate degree from MIT and his PhD from UCLA. He is a professor of mathematics and computer science at St. Louis University in the USA. He has collaborated with dozens of language communities around the world to create freely available and reusable language resources. His main focus has been on software to help Irish speakers use their language online, including a spell checker, a grammar checker, electronic thesaurus, and text input methods for mobile devices. He has consulted on the Royal Irish Academy's Folklore na Nuaghailinge and on the new English-Irish dictionary published by Angoon more recently. In 2011, he founded the Indigenous Tweets project to promote the use of indigenous and minority languages in social media. And this afternoon he's going to talk to us about corpus-based language technology for indigenous and minority languages, and he will discuss a project called Uncrubadon, which is a long-running project that involves mining the web and social media sites for texts in more than 2,100 languages. That isn't a typo, is it? No, okay. The linguistic resources we generate as part of the project are being used for linguistic research, but also in end-user applications for language revitalization. It also provides the best available picture for the true linguistic diversity of the web. Kevin is very modest in what he does. He is a demigod in Irish language, Scots language and Manx language circles. But when you go on his website and you look at what he's done, he's worked broadly on endangered languages and social media. He has spoken and researched translating Facebook into endangered languages, the statistical unicodification of African languages, and he also has long-running projects on indigenous tweets and indigenous blogs. Please welcome Professor Kevin Scannell.
So it's very nice to be here. Thank you for the invitation and the nice introduction. So I'll talk about the Corpus-based project. This is a project that's been going for a long time. So just a bit of background about me. So I'm American, but I speak Irish, which is really how I got into this work originally. My PhD and my research, and I sort of moved through the academic world as a mathematician. And only really in the last 10 years have I kind of shifted my work to be focused almost entirely on language processing and endangered language research and so on. So that work started as an Irish speaker, working on resources for my own learning and to sort of help the community of Irish speakers online. So that work started more or less when I began with the language in the early 90s. And when I started, there were no resources at all for Irish. In fact, as far as I know, there wasn't even an electronic word list for the language. So if you wanted to create a spell checker or something like that, going back to say 1995, there was essentially nothing. There were some online email discussion groups and so on, so it was sort of the beginnings of the social community of Irish speakers online, but there wasn't much in terms of useful resources. So I had some notion of statistical language processing when I started with this as a kind of outsider. So I decided I would try and crawl all of the Irish texts that I could on the web, which is what I did. And I wrote a very simple web crawler, which I dubbed Uncrubadon. So this is, if you look in Irish dictionaries, it's a crawling thing. And it's based on the word crub, which is a sort of paw, an animal's paw. So I want to talk about just the web as a linguistic resource for doing different sorts of research, either linguistic research or building the kind of computer science or end-user applications that I'm interested in. So there are upsides and downsides, and I'll talk a little bit about both. So the web as an archive. So I want you to picture sort of the traditional linguistic archives, and there are a bunch of these online. You can search these archives for languages and find either linguistic papers or the results of research or recordings that are attached to usually endangered languages. So the perspective is, how do we think about the full web as an archive in this sense? Because it's not really an archive, of course, but there are some ways in which it's like an archive. So there are billions of resources if you view web pages and so on as resources. So with the language, so the web as an archive is huge. So that's a plus, right? So it's sort of a scorecard here. On the other hand, unlike a lot of the resources, linguistic resources that are available in archives, they're not annotated with linguistic annotation or translations or transcriptions and so on. So we're talking about raw linguistic data, and that's a minus. As I'll talk about in a second, to date we found more text, raw text in more than 2,100 languages on the web. Again, broad coverage in terms of what's out there in this archive, which is a plus. But when you look at kind of the long tail of languages, for probably the majority of this 2,100, there's very little raw material out there. Oftentimes a single web page or text from a single linguistics paper or something like that. And that's clearly a minus. The web is full text searchable, which is nice, but you can't search the archive by language. So I can't say, I'm interested in Manx Gaelic, give me all the Manx Gaelic pages. Now, there's sometimes tricks for doing this, but there's no metadata in terms of language attached reliably to web pages. The web, in some sense, is archived periodically, so you may know about archive.org, or the Wayback Machine, where it's essentially a web crawler that archives the web as it stands at a given date, and you can search it and find for particular pages what that page looked like at particular dates over the last 10 years or so. So that's positive, and it's actually helped us in our work, where there have been websites that have appeared and then disappeared, websites where we knew it was the only site out there with text in a particular language, and then disappeared. We can use the Internet Archive to go back and find those resources. Unlike true archives are supposed to have unique identifiers attached to resources, and those resources shouldn't change randomly, but of course if you view a URL as a unique identifier for linguistic resources, then these things essentially change at random or seemingly at random, or disappear entirely from the web, which is a negative. Most things on the web are free to download. You can download and use it as you see fit, but it's not clear what the usage rights are. Am I allowed to use this full text for some other purpose, and so on and so forth. So that's a difficulty. And it restricts, in a sense, the sorts of things that we can do with the web as an archive. So, so how did this all start? Again, I was interested in Irish. I started trying to crawl the web in about 1999, and was finding lots and lots of text in Irish, millions and millions of words, which was encouraging. So I created a spell checker and some other resources, and was in touch with people in the other Celtic language communities, and the group that's in charge of the OED of Welsh, the University of Wales in Aberystwyth, contacted me about trying to create a corpus of internet Welsh in about 2004. So that was sort of the first big crawl that I did of Welsh web pages, and we found at that point about 50 million words of Welsh on the web, much more now. And that corpus is actually still in use by the Historical Dictionary. With the success of crawling the Celtic languages, I expanded and started looking at lots of other European minority languages, and then calling them minority languages, but for the most part, languages in North and South America, indigenous languages, languages of the Pacific Islands, Hawaiian, Maori, and so on, Samoan. Ran the crawler for those for several years. There's a series of workshops, the Web as Corpus workshops. I got invited to speak at one of those, and in the lead up to that conference, decided that I would sort of push things as far as I could, and found about 450 languages up until 2007. It was only about 4 years ago, so this was an unfunded just project that I did for my own work. But I applied for a grant in 2011, was happy to get some money from the NSF, for which I could hire students to do some of the legwork behind this, and we decided to sort of ambitiously search for every language that we could on the web. And that started about 3.5 years ago. So I've given away the answer in the abstract and, and in the first slide. So how many languages are out there? Most people here may know there are something like 7,000 languages in the world. So how many are on the web? Well, roughly 2,100. I say roughly because it takes some time to kind of process. When we find a sample text or a web page in a language, we have to create a statistical model of the language that we can use to search for more, so a language identification model. So it takes a little bit of time. We have a queue of languages where we found things and we still have to train, and there are at least 200 more. So I would, and I've looked back, I've given this talk over the years, or talks like this, and I keep having to change the slide and update it. I would say now, I think probably between 2,500 and 3,000 languages on the web. The other reason that this keeps changing, this number, is we find more stuff by searching, but there are more languages coming online all the time. And a lot of that is Bible translation. So I think the jump that we've seen over the last 2 years, most of the new material that's come online have just been new Bible translations. So for what it's worth. I'm going to do this talk probably in the wrong order. I'm going to talk about kind of the details of what it is we do and produce, and then I'll talk about some of the applications at the end. So I think the more interesting, fun things will be toward the end. But I want to say a few things. We have some computer science folks here. I'll talk about a little bit about the design of the crawler and how we process the text to try and produce useful resources for researchers. So the first principle is that I keep talking about languages, 2,140 languages, but that's not what I mean. I mean orthographies. So we distinguish, say, Greek as written in Greek script from Greek as written in Latin script, as an example, or Chinese and traditional Chinese script versus simplified, and so on and so forth. In certain cases, we distinguish dialects, even when there would be a single language code attached to a language. If we can reliably distinguish dialects, then we do so, and so on and so forth. We label these orthographies with what are called BCP 47 codes. This is a standard it's intended for labeling content on the web. So if you have a web page, you're supposed to attach a language code to it so that web crawlers and search engines know that this is in Irish or English or whatever. Of course, people don't do this reliably, but it's a sort of carefully thought out standard for how to label sort of exactly the things that we want to label. So here are some examples. That's the label for English. It's a 2-letter language code, and then Cherokee, and then some more exotic examples. That's Serbian written in Latin script versus Cyrillic. It's written in both. And you can use, so that's a script code, LATN. You can have country codes. This is German as spoken in Austria. Occasionally, there are no official codes for things that we want to label, and there's a mechanism in the standard that lets you insert an X and then attach whatever you want. So this is our made-up code for Norman French, and then similarly, the last one is there's actually 2 varieties of Greek in Latin script that you see on the web, at least 2. One is sort of standard transliteration that you might see in an academic paper about Greek, but then there's the version that people type on their phones and so on, or on Twitter when they're tweeting in Greek and maybe don't have a Greek keyboard input. So we call that EL-Latin-X-chat. There's a similar one for Arabic as well. So Arabic has sort of a standard academic transliteration and then also a chat version as well. And so the idea is, like in Greek, like a theta, I think, is an 8, a number 8. So it resembles the letter in Greek versus being a TH, which would be sort of the correct way of capturing We try and capture real text, so we're not so interested in dictionaries or word lists in these languages. We want real corpora. And well, we have some interlinear text from linguistics papers, but we try and find running text in the language. And then we hope to get, for the languages which don't have a big web presence, everything that's on the web, if possible. And then for the bigger languages, we're sort of set up to crawl billions of web pages, so we just get big samples. And honestly, they're not very well sampled, so I think there are better ways than our corpus collection for doing language processing in English and French, and so on. But at least we have samples for these. So the way we find languages is through a lot of manual hard work and detective work. So we have a big spreadsheet with 8,000 or 9,000 different imaginable BCP47 codes, and I set my students off, and I've spent 10 years doing this, just searching. There are several sites that are highly productive. This is kind of the theme of this. So Wikipedia has 289 something translations. There are also Wikipedia incubators, maybe another 100 of those. So these are reliable places to get raw text in these languages. That said, a lot of people in language processing circles will just grab a Wikipedia and say, here is lots of text in the language, but you have to be very careful. So in reality, for a lot of the smaller Wikipedias, it's a mix of in-language and out-of-language. Not many people know this. They just sort of grab, say, the Igbo Wikipedia, assume that it's all correct, but usually, or often, it's not. So you still have to do language ID on individual pages. JW is Jehovah's Witnesses. This is one of the most multilingual websites that there is. JW.org, if you're curious. It's a successor to a previous version called Watchtower.org. It's now gone, unfortunately. Most of the languages have been carried over to JW.org, and there are hundreds of language versions available. The UN has lots of multilingual documents, and then of course there are Bibles. Bibles make up a good chunk of kind of the long tail of languages that we have. Occasionally, when we have no other source for a text, or all we have is a scanned page image from some language that's on the web, my students will actually transcribe it and type it in, or do OCR if it's long, and then correct the OCR so that we actually have a sample for the language. Sometimes we get lucky, and they'll type in a single page, and then we have sort of the beginning of a corpus, 1 page worth of text. We can take some of the words from that page and feed them into a search engine automatically, and then occasionally get lucky and find additional texts in that language. More often than not, we'll have them transcribe a single page, and that's all we have from that language. And then, as I said, we build statistical models for doing language identification. So once we've identified some text in a language, I can set the crawler to search for more text and hopefully reliably recognize the language of the documents that we crawl. This becomes much more challenging. Most of the papers that are written on language identification experiment and report results for maybe 50 languages or 75 languages. So trying to do it reliably for a couple thousand languages is a significant challenge. Special thanks to a master's student at George Mason University, Ed Yan, who's himself trained probably a couple hundred of the models that we have so far. He's been sort of an active collaborator and enthusiast about the project for a couple of years. And then, of course, the NSF has funded us for the last 3 years. So beyond just collecting the text, we try and produce resources that people in language processing can use. And this means doing more than just taking the raw text that we collect and distributing it to people. So one thing is that we try and separate out different orthographies and different dialects of the same language. This would mean, for example, in Irish, distinguishing pre-standard orthography of Irish from modern Irish. I've also experimented with distinguishing, say, Connemara versus Munster Irish versus Ulster Irish as well. Web pages often have a lot of noise. They'll have navigation, home, various bits of navigation, language buttons often. You'll see click here for English or Welsh or whatever. We try and clean that text out so that what's left is kind of the raw text of the page. Similarly for blogs have a lot of noise beyond just the content of the blog posts themselves. We try and clean that out and get raw. And then the biggest, hardest thing that we do is probably the most boring sounding thing to everybody, including the computer scientists. We convert the text to Unicode and we normalize the text in various ways to make them useful for language processing. And I'll say a little bit about this, even though it's boring, I feel like it's the heart of what we do in some ways, and it's worth mentioning. We segment the text by sentences and then do our best to tokenize them into word lists and create word frequency lists. Cool. So then we don't have much metadata. I'll make this point in a second, but basically the metadata that you have with web pages is really limited. So we have a URL, I can tell you about the timestamp of when we downloaded it. For most pages, there's a page title, which sometimes isn't useful. And then we can crawl like Word documents, PDFs, HTML, and so on. We keep track of what the original format was before we converted it to text. And then, of course, the most important metadata that we add to the system is the language tag, the orthography tag. And it's worth saying, if anybody has experience looking at raw web data, it's possible for an author of a document on the web to specify the language that they think it's in. And I don't have the numbers, but I would say 95% of the time these tags are wrong, right? So you go to the Irish web and you look at all the pages, a tiny fraction of them would correctly mark the text as Irish. So it's a bad idea to try and use these either for language ID or for searching texts. And then similarly, there's a last modified header on a web page that says something about when it was created or last changed, and again, 90% of the time it's useless. So here's this Unicode bit that we work on and spend a lot of our time on. And I'll explain with a couple examples why it's so important when you are looking at kind of especially the long tail of languages. So for many languages, especially ones that sort of emerged on the web before the advent of Unicode, they created special fonts to represent the language. So Mongolian is a good example. Mongolian is often written in Cyrillic script. And the problem is that Mongolian uses various characters from Cyrillic script that aren't part of the standard Russian Cyrillic alphabet. And the way they handled that was they encoded the documents using the Russian encoding, but then they used a font as sort of a trick. So characters that are different in Mongolian, they essentially created a font which just drew those characters differently when appropriate. So to the computer, setting aside the font, right, the underlying text is incorrect, right? If you look at it as a computer scientist, or you try and naively convert it to Unicode, you get a lot of the characters incorrect because you're converting it to these Russian characters instead of the correct Mongolian ones. That's a huge problem, especially for sort of legacy texts from the 90s, early 2000s, and it's still a problem for some.
I'm sorry. Did they take code points that weren't defined, or
No?
They took code points that were already defined.
They
They
did.
no longer use the character corresponding to the. Okay, so they substituted.
They substituted.
It wasn't anything more complicated.
No, it's just a font that
Okay.
that substitutes the character for what is properly the Russian character. So, and of course, this was before, in most cases, before Unicode. So, and it's a problem for Sami text as well, and literally dozens of others. And in fact, we don't even really have a survey of this problem really broadly. It's just as we come across a corpus on the web and we see that there are problems, then we have to solve it. And oftentimes it means reverse engineering the font because there's no information about the fonts on the web. So it's tough. It's hard work. Sometimes people just honestly type a the incorrect character when they're typing on the web. So Azerbaijani is usually written in Latin script, but with some unusual characters like the turn E. And of course, they probably look the same from your perspective, and maybe in this font they're identical, but one is Cyrillic and one is Latin. And if you look at Azerbaijani texts on the web, you'll see a mix of the two. And sometimes it's just because it's easier for people to type. And if it's easier for them to type, then it looks the same, and they don't care, right? But if you want to do frequency lists and language modeling and so on, it's important to get right. The middle one is Buryat, which is a language close to Mongolian, and then of course even Romanian, this is an issue. So Romanian, that's an S with a cedilla, and then an S which is properly supposed to be a comma below the S. And you see it on the web, even nowadays in Romanian, you see a mix of the two. In Polynesian languages, many of them have macrons for long vowels. Before Unicode, it was relatively easy to type vowels with either acute accents or a diaeresis or something like that, so that's what people did instead of actually properly typing the characters. So in terms of creating useful corpora, we'd like to take those incorrectly encoded texts and fix them. And then of course there are additional encoding issues. So this is Setswana and Northern Sotho. They use an S with a caron above it, which is not in the Latin 1 character set. It's in the Latin 2 character set. When people put these texts online, oftentimes the metadata says, oh, this is Latin 1. Again, if you naively convert it to Unicode, that nice S with the caron comes out as a beta SS, yeah, sharp S, sure. So what you find is you find texts that are Unicode, but where they have a bunch of incorrect characters because they were just sort of forward ported from an incorrect encoding in the past. And then of course, this is, I spend so much of my life dealing with apostrophes. It's absurd. This is a collection of different Unicode code points that all represent either apostrophes or apostrophe-like characters. And if you speak a language that makes heavy use of apostrophes and you look on the web, you will find a bewildering variety of these. So for Irish, for example, and even in English with an apostrophe S, if you look at the web, I mean, it's generally speaking either an ASCII apostrophe or sort of the correct term, Unicode apostrophe. But you'll find lots of others as well. So normalizing means getting that all correct. I'll zoom through some of this. So tokenizing means just breaking the text up into words, and it varies from language to language, of course. We have a default tokenizer, but then in certain cases, there are a bunch of languages that are generally speaking Latin script, but they'll use some Greek characters, and you want to make sure you get that correct. Catalan has a character which is a center dot that appears only between a pair of L's. In essentially loanwords. And there's a variety of characters that are used for that. If you break your words on punctuation marks, right, naively, then this would be treated as a punctuation mark, and you would split the words in two. So you have to, sort of language by language, keep track of which characters are used word internally. And then, of course, apostrophes. As always, many languages use, English doesn't often, but many languages use apostrophes at the beginning or the end of the word. You have to keep track of that. So, the crawler has three parts to it. There's a traditional web crawler that just scours the web for pages in these languages. And we also crawl tweets. That's part of the indigenous tweets project I'll talk about. And then we collect blog posts as well. So the Twitter crawler is based on Twitter's API, which makes tweets available to people who want to do various interesting things with them. We have the corpora from the web and the statistical language ID models from the web. We can use that to try and find users that are tweeting in different languages by searching. And then we apply language ID to their tweets. Now the tricky part here is that identifying the language of a tweet, which is usually very short, less than 140 characters, can be very difficult. So the solution to this is more or less to look at a user's tweets on the whole, right? So you get a larger collection. We try to identify people who are tweeting in language X at least some of the time, and then essentially build a sort of a model of that person's tweets, their language behavior on Twitter. And then it's possible, once you find some people tweeting in language X, you can use the social graph to find more. So if I know that Brian is tweeting in Irish, I can look at the people who are following him. Presumably, if he's tweeting, say, 90% of the time in Irish, then presumably they at least read Irish, and maybe they're tweeting in Irish as well, and so on. So we take advantage of that. And then all this data is collected on this website that I started in 2011. The idea being to be sort of a directory for people. So this is the Basque page on indigenous tweets. And it's really just a directory. So these are the top 10 or 11 accounts. You scroll down, there's the top 500 accounts of people tweeting in Basque. We do trending topics in the language as well, by just doing language ID and then finding the trends among the Basque tweets. This is actually one of the things that people like the most. It was just sort of an afterthought, but if you speak Basque and you live in the Basque country, or you speak Irish and you live in Connemara, there may be something that's really trending among Irish speakers, but it's rare that it would bubble up and become a trend in Ireland or the Basque country. Sometimes, on very rare occasions, it's happened, but not very often. So the idea is that some sort of a menu that if you're a speaker of this language, you can go on and decide who you want to follow. And we also collect blogs, so from Google's Blogger platform. And it works together with the traditional crawler, because they're just web pages. The crawler will find text in a blog, and then the blog tracker registers that blog as blogging, maybe sometimes in Irish, for example. And then we make sure that we crawl that blog in totality, right? So it's possible to pull down all the posts and then check them all, and guarantee that we'll check them all going forward in the future. And we created a similar site, indigenous blogs, for tracking those. Again, the nice feature that people enjoy about that site is it gives you an idea of who you can follow, which blogs you can follow, but there's also, if you know about these things, it's possible to register with an RSS feed per language. So with one click, you can get all of the blog posts in Irish in a single stream. And if you're, like me, interested in just reading Irish blogs and not English, then it filters out all of the other ones. So all of this stuff is available on this site, cribidon.org. This was just launched less than 3 months ago. And we have per language or per orthography landing pages with some metadata about the orthography, and then a downloadable zip file that has various things. So we have word frequency lists, bigram frequency lists, character trigrams, which are part of what we use for identifying language, and then a list of all the URLs that we found in that language. The list of URLs I expect to be kind of useful. A lot of people have their own tool chains for crawling and so on, especially people that are doing language processing. So in a sense, this could be a start for somebody who wants to do a big crawl of Slovenian or Swedish or something like that. And then it's registered as OLAC is the online language archive consortium or something. But it's a site that has sort of like a meta site that has metadata about all of the different things and all of the different linguistic archives around the world. So we're sort of treating cribidon.org as a linguistic archive and registered that with OLAC. Okay, so I just want to talk a little bit about some of the applications of these corpora, or at least the things that we've done with them. So spelling and grammar checking was something that I started with Irish as a learner of the language and someone trying to use it online. So I created a spell checker based on web crawling and lots of hard manual work cleaning those word lists in about 2000. It has about 350,000 words in it. A grammar checker 3 years later, which again is based sort of building on this foundation. The grammar checker takes into account, so for the Irish speakers, it catches most of the typical mistakes that people make with initial mutations, for example. So that's in Gramador. And then I've been working with language communities on, we call them just basic language technologies. For many communities, the first thing that they want is often a translation of basic websites. So they'd like to be able to go onto google.com and see their language and so on. And well, that's a whole separate story. I work a lot with software localization as well. But the next thing that many communities want is a spell checker so that people can write the language. And there's a lot of sort of sociolinguistics going on with spelling and spelling standards and so on and so forth. But this seems to be, especially among African languages, minority languages of Europe, communities that are online and want to use the language, they view this as an important first piece of technology. So we've created 28 spell checkers since 2004, all of them open source, and all of them in collaboration with communities that want them. So just a couple words about spell checking. There's an open source spell checking engine called Unspell. It's now kind of the standard tool that people use when they want to create a spell checker. It's integrated into Firefox and OpenOffice and all of the standard open source applications. As I said here, it's fast, it's powerful enough to handle lots of different language structures and so on. It has, to this point, about 150 languages that are supported. And it can be as simple as a word list. So for English, you do fine just with a word list of, say, a couple 100,000 words. But for languages that have complex morphology, it's possible to encode some of that morphology as well. I thought I'd just say a word about that. So there are kind of two main approaches to dealing with word morphology in terms of computer science. So one approach is what we call finite state technology or finite state transducers. And for the purposes of this talk, it's essentially just a tool that allows you to encode the morphology of the language in a relatively compact way. I'm a big fan of finite state technologies and transducers. They're very fast. They work in both directions. So what this means is you can take a word that you see in a surface form that you see in a text and analyze it and say, yes, this is in the language, and it's a verb, and it's in the present tense, and so on. You can also generate, so I can tell you what is the first person present of the verb in Irish or something like that, and generate that form correctly as well. So it works in both directions. For spell checking, of course, we're interested in the analysis direction. The difficulty with the finite state tools is that there's a relatively steep learning curve in trying to use them. But they're very powerful in terms of the formalism. So finite state techniques cover most of the phenomena that you see in morphology of human languages, with some known exceptions. Hunspell uses a weaker formalism, they call it twofold affix stripping, which is not powerful enough to handle all of the world's morphology. And basically it's for analysis only, again, because it's focused on spell checking. So we've used a mix of both. So the last point is that Hunspell is integrated tightly into the tools that people are using, mobile devices and Firefox, typing in Gmail or OpenOffice and so on. So most of our work has been focused on Hunspell, even though it's not as powerful. The fact that you can put it into the hands of people who want to use it online is super important. And then just, since some linguists here, just a few words about whether Hunspell is indeed powerful enough. So Hun in Hunspell is for Hungarian, so it was written by Hungarian people. Hungarian is complex morphologically, and it's powerful enough to do a good job with Hungarian morphology, so that's a win. There's a Hunspell spell checker for the Sami languages, created by a group in Tromsø. Trond Trustrud and his group have for Northern Sami and the other languages as well. There's a Hunspell spell checker for Basque. I don't know how good it is, but these are all very complex languages morphologically. So I've created, so those are all done by other people. I've created, I'm interested in Bantu languages, so I've created Hunspell spell checkers for these 4 Bantu languages that are structurally all reasonably similar, and it's certainly powerful enough to handle these. I'm working on a project right now with a First Nation community in Bitigong in Ontario, and a brilliant programmer named John Paul Montano, he's a programmer and a language activist in this community. I strongly suspect, knowing what I know about the morphology of Anishinaabe, that Hunspell is not powerful enough, and we're going to have to resort to using the full power of the finite state tools. Okay, language identification I mentioned is an important part of the stuff that we're doing. It's a component of the web crawler, but it's also in a sense an application. So we're collecting all this data, and we can create models of the different orthographies and use it to do language ID. So we use a mix of character models. So what does the language look like at the character level, and then what does it look like at the word level for doing language ID. We released a few years ago, in fact, a data set of the character 3 grams that's now sorely out of date. It's better probably to get the data set from our website now. We should probably update the NLTK data set. And then of course the 2 sites I mentioned, the indigenous tweets and blogs, are essentially driven by language identification. That's what they are in a sense. We do a lot of stuff. So Brian asked before, he didn't know what text input on mobile devices meant exactly, so that's this bit. An easy thing that you can create just if you have a plain text corpus in a language is you can do predictive text. So as you're typing in, this is actually Manx right here, as you're typing along, the predictive text model will guess what the most likely next word that you're typing is, or the most likely completion of the word that you've started typing. And we have this deployed various places. Some examples of T9 input, so that's the old school 0 through 9 phones, which is even more challenging. And then we have a program called Adapt Text, that's the one that's pictured here. That's a predictive text app for Android. Working with Mozilla on their new mobile operating system, Firefox OS, to provide predictive text dictionaries and so on for many of the languages they're launching, many of them in Africa. And then Dasher is a project that was run years and years ago. That was a text input method that was aimed at people with disabilities. So it's worth a look if you're interested. This is a project of a student of mine. It was sort of cute. It's actually not, it's offline at the moment, but it's sort of a cute idea. The idea here is diacritic restoration. So if I give you a text in a language that makes heavy use of diacritics, if you look online, if you look on Twitter and Facebook and so on, generally speaking, people leave off the diacritics completely, and you just get text with A through Z and no diacritics at all. Properly speaking, this is Yoruba. This is what the text should look like, with all of the tone marks, and we have dots beneath various vowels and so on. But online, people tend to type what you see at the top. So the idea of this service is that it'll take this text and automatically produce this text for you. Right? So my student created end user clients for this, so you can be typing an email in Firefox, so it's a Firefox add-on. And if you're typing in Irish, for example, you can just type without worrying about the Shintifada. And at the end, you just right-click, and it adds all the fadas for you, which is nice. Yeah, I know.
Guess what you're doing after this.
Yeah, right. It works very, very well for Irish because we have lots of data and it's good dictionaries, and so it's part dictionaries and then part kind of language modeling. For a language like this, where there are many diacritics And so it's a chicken and egg problem. To solve this problem in Alpha Yoruba, we need lots of text from the web, which has all of the diacritics on it. And there isn't much because people don't have the tools for typing it. So it's a sort of serious chicken and egg problem in many cases. And then we have libraries, so if you want to use the service in your own programs, you can use it. And Michael Shade is my student. He's now long gone. He's working at Stripe in San Francisco. And then there are some lexicographical projects. We're feeding corpus data. I mentioned the Historical Dictionary of Welsh, the new English-Irish Dictionary. This is the Historical Dictionary of Irish at the Royal Irish Academy. And then Sketch Engine is a really cool lexicographical platform. And we provided corpora for lots of kind of middling-sized languages to the late Adam Kilgariff, who was a hero of mine in lexicographical circles. And then finally, we are producing n-gram language models. So for the computer scientists here, well, this is what I talked about this morning with called the Markov Models. So the idea of predicting the next word based on the 2 or 3 previous words. And this is the talk that I gave this morning. We're using them for machine translation into Irish from Scottish and Manx Gaelic. We have an Irish standardizer, so I've mentioned a couple times the spelling reform that occurred in the late 40s, early 50s. For the dictionary projects, a lot of the really good, rich Irish text was written in the 1930s and 40s. So it uses the old orthography when they want to use it for lexicography. I mean, even just to be able to search in those texts, they want to be able to index them by their modern spellings. So the standardizer it's really a machine translation problem, right? You're translating for 2 really, really closely related languages. And that's how I sort of set it up and implemented the standardizer. And there's parallel data too. So there are manually standardized texts from that era that were republished in the 1990s, 2000s that we could use as training data for this.
Based on what you're saying, would it be possible to take pre-standardized texts with all those silent consonant clusters and just modernize it?
Yeah, that's what this does. Yeah. That's another project for us tonight. I can demo. I mean, it's not perfect, like any machine translation. It's going to make mistakes, and
so those 1920s, 1930s on Google translations of English classics could be
modernized, and that's what the Royal Irish Academy Dictionary wanted me to do, because they have all of those texts as part of their corpus. And again, they're not interested in publishing the modernizations, right? To them, it's a sort of device for searching, right? So I can index and say, think of all the different imaginable spellings of Gaeilge that you might see in those texts, with silent consonants and so on. And so index them all so that if you search for just Gaeilge in the modern spelling, you can come on any of those. You can use these for speech recognition. I provided them. I'm not working on this myself, but provided models to people working on this. And then sort of a simple application in the same domain. These texts from the 30s were all printed in old Irish fonts, and to create digital text out of them, corpus text, you have to scan them and OCR them. But of course, the OCR is very bad on the old Irish fonts. So we have a program to correct the mistakes, and it uses language modeling as well. And then I'm not a linguist, but lots of people write to me when they find out about these corpora, and I give corpus data to lots of people doing research, and you name it, phonology, syntax, morphology, people doing psycholinguistics, selection preferences, and so on and so forth. And then just one fun project. This is now 4 years old, but I took the language ID models, and it's possible to measure distance between 2 languages, just statistically. And once you can measure distance between two things in a set, you can sort of reconstruct a family tree. This is kind of well-known stuff in computer science. Take the two closest things and say, okay, these two are neighbors, right? And then it's going to merge them together somehow, and then take the next two closest things and work your way up the tree. So this is what a tiny piece of what it looked like when I took 1,000 language models and ran this tree. And what I did was sort of cute, but I colored the actual known linguistic family trees with the same colors. And what's happy surprise, or maybe not surprising, is that the family trees line up, sort of the known linguistic family trees line up with this really sort of naive clustering according to just purely orthography. So,
what is the metric for the orthography?
Yeah, so for this particular thing, I looked at character sequences. And
if they're shared, or?
Well, so you can do various different things. So you think of it as it's a distribution over all of the triples of characters, right? Because you have frequencies for everything. And once you have distributions, there are lots of ways of measuring the distance between two distributions. So one approach would be to treat it as a vector, and then there's sort of cosines. You can treat them as two vectors in a big high-dimensional space, and so how close are those vectors? There's divergence, and cross entropys, and you name it. So, in any case, that's sort of a cute thing. And then, final slide, if anybody's interested in collaborating, we've had more than 100 people collaborate and either point us to language data or help us split dialects and orthographies. When we give them a corpus and they say, oh, this is really sort of like Northern Sicilian and Southern, or whatever it is, and they'll say, this blog is dialect X, and these blogs are dialect Y, and boom, we can create separate models. Of course, they help us with the normalization step. We make mistakes all the time, and they say, oh, this Cyrillic character is really supposed to be this one. You need to correct that in normalization. So a lot of that I shouldn't take credit for. That's just people telling us the right way to do it for their language. And then, of course, finding new material. And finally, for the communities to actually help create new material online. So if we can encourage people to create Wikipedia or articles and so on, then that sort of feeds this cycle. And then, of course, anybody who wants to collaborate on spell checkers or morphology engine and so on is welcome. So that's all I have.
I presume you'll take some questions if there are.
Please.
How accurate is your language identification?
That's a good question, yeah. So we haven't done careful evaluation.
Okay.
So you will probably want a number. I have kind of impressionistic things that I can say.
Okay.
It's like, I mean, if you read, I've read all of the research on this, right?
Sure.
And everybody points at the same variables, right? So length of the text is a big thing. And I certainly agree with that. But one thing I don't think people really appreciate when you get to 2,000 languages is when you start getting really close pairs, right? Like, it's not very hard to distinguish Portuguese and Spanish, for example. People think of that as, oh, these two really close languages, but for a lot of the ones we're doing, it's like you're trying to distinguish British English and American English, right? Which is significantly harder. So the real answer to your question is, I don't know, and the whole system is sort of cooked up so that we don't fail. So when it's too hard to distinguish, we give up and we say that's one thing, right? And that's pretty rare when they're separate language codes. But for dialects, especially when we start to divide things up, if we can't distinguish them, we say, to the ability that we have, that's one thing. So that's my best answer.
How much mixing do you see of languages in a single web page? Like,
it's pretty common.
A lot. Yeah.
Yeah. So the way we do it is, if there's some fixed percentage, we set a cutoff. So there has to be maybe say 20% of the page in a language, then we keep it for that language. And then when we create the frequency list and n-grams and all that, we filter out all of the rest.
So you do attempt to identify the spans of the page that are in the language of interest?
Yeah. So that's an added value too, right? Because
Yeah.
it gets tricky, of course, because then you get mixed, in Irish, if you look at Irish newspapers and so on, there'll be long quotes in English in the middle of an otherwise Irish paragraph and so on. We leave that. It's just like, it's a complex world, and the stuff that you see out there is messy and complex. So, but we do split on paragraphs. It also depends on the application, is worth saying as well. So, like how much cleaning and filtering we do. So I kind of learned this from dealing with the lexicographers. So I fell in with the people in Wales, and I said, how much cleaning should I do? Should I get rid of the English and so on? And they said, don't clean anything, right? So the lexicographers, their greatest fear is that they'll miss out on some word. And they said, like, we'll go through the 150,000 words and we'll just get rid of the English, right? So they were much happier. So that's kind of the one takeaway for me, is that it just depends on what you want to do. If you want to do language modeling for MT, then maybe this is really important, but for other things. So the stuff that we put out, we tend to be very gentle cleaning, and then if you want to do more later, you can.
Okay, so we have teas, coffees, those pastries. So can we thank Kevin for the talk?